All right, so we're going to talk about the substitution rule. And so what the substitution rule is basically, um, it is basically chain rule in reverse. It's the reverse chain rule. Basically, that's how it works. And so let's pretend I want to find the derivative of this. Now here, I have a multiplication of 2x times this. And I really don't know how to handle this quite yet. I just don't. But here, if I make a substitution of u equals to 1 plus x squared, and then I do its differentiation. So um, let me kind of explain how this works out. So here, now if we didn't do too much of total differentiation, but it kind of comes up a little bit. So here we do total differentiation here. If I total differentiate this becomes du, and then this becomes nothing plus 2x dx. So that's how total differentiation works. And so here, I want to solve for x. So dx is equal to, let me just do it so it makes that dx, right? So dx equals du over this. And so here I can just plug in u and dx. And so if I do that, I get 2x square root of u, because that's what I made u. And then here for dx, I'm going to plug in du divided by 2x. Well, here I can just cross this off safely. And that leaves me with the square root of u du, which is equal to square root of, let me do this as 1/2 du. And then this is easier to see. Here I raise this by 1, so this is u to the 3/2, and then I divide by it, so over 2/3 less than c. Okay, but what was u originally? U was 1 over x plus squared, so we can just type in 2/3 over 1 plus x squared to the 3/2 power. Okay. Now, one thing you can use, we could use the fundamental theorem of calculus. So we'll just take the derivative of this real quick. If I take the derivative of this real quick, I should get back this, right? So let's take the derivative. In order to the derivative, we're going to replace this with u, right? So here I get u to the 1/2 power divided by, so these would cancel, times du. Well, du is 2x, or du dx, which is 2x. So that equals 2x, and then square root of u, which is 1 plus x squared. So this just shows that if I took this is the correct integral. So this is just a quick way to check. You just take its derivative. Okay. Okay, well, we have two questions. Is there attendance today? No attendance today. Is the discussion week this week extra credit? Yes, the discussion week this week is extra credit. That's why it says 0 points. Okay, so you can make up some discussion points. And no, we're not taking attendance today. Okay. All right, so let's do substitution. So here's the substitution rule, and it's kind of in its more formal state. Here, if I have a function of another function multiplied by the derivative of that function, I can just replace it as I can just integrate this with du. So let's look at what we have here. Let's look at this. So let's pretend. So here, I'm looking at this and I'm trying to think what's the thought process here. This doesn't look like anything I know how to integrate, right? I don't know how to do x cubed times anything, or cosine times anything, I don't. But notice here, if I took the derivative of what's inside here, it looks an awful lot like that. Not quite, but an awful lot like it. And so let's just go ahead and crunch through it and see what happens. So here, we're going to say u is equal to what's on the inside here. Let me clear this up so you can see what's going on. We're going to say u is equal to x to the 4th plus 2. that means du. So you just total differentiate that. So it just becomes every time you see a variable, you go ahead and do this. And then if you see this, you do the chain rule. So it'd be 4x cubed dx. So that's what you write here. So it would be this, take the derivative times dx. And this comes from total differentiation. If you forget that, just go ahead and take the derivative of every variable and then just add a du or a dx. You should be fine. I can't think of any problems you'll solve here, which that will become an issue. Okay. And then this 2 just, of course, comes to 0. And then we replace this du. We solve it for dx. So we have dx here. So we'll have du over 4x cubed. And then you just plug that all back in here. And so here I'll have x cubed cosine of u times du for x cubed. Now, this doesn't exactly match, but it's good enough. So I cancel out this. I have a fourth, so I'm going to just pull that out. So I have 1/4 cosine of u du. And this is something I can integrate quite easily. Cosine goes to sine. So the antiderivative of cosine is sine. So it'll be sine of u plus c. And then I can plug in what I know u is. U is this. So I get 1/4 sine of u. Or no, I'm going to plug in u this time. Plus some c. And there we go. Okay. All right, I'll give you a second to write that down. So all we're doing here is we're looking at these integrals and we're going to do chain rule in reverse. We're going to have a function of another function. In this case, we had cosine as a function of x plus x to the 4th plus 2. And we notice that the derivative of the function of the other function, in this case, the derivative of this is outside. So that usually triggers you should use substitution. Now, does substitution always work? No. Is it going to work for all the problems in this section? Yeah, it's a book, right? It's designed to work everywhere you see this. So it's just another tool to have in your tool bag to solve equations. All right. So let's go ahead and go to the next page. So let's look at this. So what do we have here? We have something kind of complex. So we're going to guess that we want to make all of this u right here. And so we're going to say, sorry, one of my dogs is having a dream. So here we're going to say u is equal to 1 minus. Now the reason I chose this to be my u, not this, because the derivative of this is not x. The derivative of this is x. And so there is some thought process on how you choose your what you set u to be. If I set u equal to this, the derivative here I know is something x, right? In this case, it'd be like minus 8x, right? If I took the whole square root, which is fine, but the derivative of this is not this, and so you kind of have to think kind of a step ahead, and so you'll do a couple of these before you get to that point. So we're going to just go over it. So here, so du, remember just take a total differentiation here. So if you see a variable, type in du. Constant, of course, would be 0 minus. Go ahead and take the derivative of this, which would be 8x, and then if you take a derivative with respect to x, you have to add the dx. We're going to solve for dx. So dx is equal to du over negative 8. And then we're just going to plug it all back into here. So here are the integrals between x. I'm going to pull off the x and leave this as 1 over square root of u. You notice if I have it up top, it's the same thing as just multiplying it on the side. I'm going to put a du here. So dx equals du times negative 8. Oops, I forgot my x, didn't I? All right, so this x cancels this x. And you know if you did a good substitution, if, I'm going to just pull out the -8, there's no reason to leave a constant in there. You know you did a correct substitution. If you remove, if all your x's disappear. So if you did it correctly, there should be no x. There should be no x's at this point. I really remember saying that, not correctly, but if you chose a good substitution, there should be no x's when you hit that. If there's still an x, it wasn't a good substitution, and try something else. Let me just try something else for this section. Now, in real life, you're going to have to discern, is it a good time to use substitution rule or not? Luckily for this class, all the problems in substitution in 5.5, you'll need to use substitution rule, and it should work out. Okay. So here we have this, and then here I've simplified it, so it just makes the integration easier. So the antiderivative of this would be so this is the -8. Here I just divided out. I just divided all this over, and I just forgot to write the x. And so this x cancels this x, so I get to here. The antiderivative of this would be, you add 1 to this, so it would be 1/2, so it would be u to the 1/2 divided by 1/2, which is the same thing as multiplying by 2, and then, oops, I forgot to multiply by my -8. We add our c. Okay, and the last thing we need to do, this is the same thing as square root. So this is -1/4. So the 2 and the -8 becomes -1/4. U to the 1/2 is a square root. What is that? Square root of all this. So square root of 1 minus 4x squared plus c. Okay, so this is our answer. All right, let's do this one. This one's a little bit more simpler. So here we have e to the 5x. I have not taught you what e to the ax is yet. I mean, you probably guess what it is, but let's just do it using this, because this will be useful for other things. Like, and I'll show you another example where this could be useful. I'll probably just put it right down here. So here we have u to the ax. So we're going to let u, so du equals 5 dx. So dx equals du divided by 5. And so here we can have the integral of 1 over 5 e to the u du. And that just becomes 1/5. 1/5. Notice that we have no more x's here. E to the u, because e to the u, the antiderivative is that. And I just plug it back in the 5. And so I get 1/5 e to the 5x. Okay. Now, standardly, e to the ax dx, the integral for that will be 1 over a e to the ax plus c. Okay. That's standard what it is, but here we use substitution to show that. This is, here we do another real quick one. Let's pretend I had this, do the square root of 2x plus 1. I would just let u equal to 2x plus 1. That means du equals 2 dx. Means dx equals 1/2 times du. And so if I was doing this, I would get 1/2 the square root of u du. This, we add 1 to it, so we already did that. So this becomes u to the 3/2 times 2/3 divided by times the 1/2. I'll cancel. And here I get 1/3 2x plus 1 to the 3/2 And so here we just have a simple square root with something in it. We can use, for the e to the x, it's kind of, this one you could probably done in your head. You wouldn't have to use substitution. But for something like this, where you have like the square root of like 2x plus 1, doing the replacement here. So notice here, I just have a square root of some function. But if that function is of degree 1, right, so it's 2x plus something, substitution is a great way of handling this. Notice this is a degree 1, because when I do my total differentiation here, I don't get another x, and so I can cleanly replace it. I also use this. It's u to the, this is u to the 3/2 times 2/3. So that's the anti-differentiation from here. And this is the half from here. And I forgot my c, sorry. Okay. So this is u to the 3/2 over 1 over 2. It's the half I pulled out from here. Okay, I hope that answers. Sorry, this is just like a side problem. If you don't have the side problems when you turn in the notes, I'm not going to be worried about it. Okay. All right, so let's do 1 over tangent. I don't think I've given you this yet. I might have, but I don't think I have. So this time, there's nothing really to replace, and I don't know if I've given you what the answer is for this one yet. But let me show you how to do it. So tangent is, of course, is sine of x over cosine of x dx. So that's the same, right? These are the same. So I'm going to let u equal to cosine of x. That means du equals the derivative of this, so minus sine of x dx. And the reason I chose cosine, you can choose sine or cosine, it doesn't matter. You'll get to the same answer, right? Is that this cleanly defines what I want. So here, if I plug this in, oops, I'm going to write dx is equal to du over the sine minus sine of x. So what do I get here? This becomes 1 over u times the sine of x over du over minus sine of x. So that cancels that. So I'll go ahead and pull out the negative 1. The integral of 1 over u du. Well, 1 over u, if you remember, is equal to minus the ln of the absolute value of u plus c. Well, let's plug that in. So here I get minus 1 ln of cosine of x, absolute value of cosine of x plus c. And this is okay if you left it here, but I can go ahead and take it one more step. So remember the negatives turns in, so remember for your log rules, we did do this in this class. This could be put onto there. Sorry. The absolute value of 1 over cosine of x. What am I doing here? Let me make this real clear. If I have x, that's the same thing as ln of x to the minus 1 power, which is equal to ln to 1 over x. So that's what I did here. And where x in this case is cosine of x. And then I can simplify it to what you would look up on a table. And that'd be secant of x plus c. Okay. So the derivative of tangent is this. So what do we do here? Well, I knew if I took here, it didn't make any sense. So we just converted it to sine and cosines. 90% of times, if you have problems with sine or any of the trig functions, just convert it all to sines and cosines and then clear. I do the same thing when I teach trig identities, trig substitutions. Just move it all to every trig identity can be written as a sine, or every trig function can be written as some sine or some cosine. So if you get lost, that's just the way to deal with it. And the nice thing is that the derivative of sine is cosine. and the derivative of cosine is minus sine. And so that helps you to do stuff like this. All right, let me let you write that down, and I'll take a drink, and then we'll do our last page. All right. Oh, okay. I was like, what are we doing on this last page? Didn't we just do everything? We're going to be doing substitution for definite integrals. Okay, so now if I have a definite integral, instead of adding the plus c, I can just go ahead and change my bounds. Okay. What I mean by that is I'm just going to figure out what is u of, or plug in my function g right here, where u is equal to g of x. So I'm going to just plug in the function. Well, this is easier explained than, it's easier shown than explained, if that makes any sense. So let's look at this. Here, I'm like, I don't know how to do this, but I do know how to do. I'm just going to say that u is equal to 3 minus 5x squared. That means du is equal to nothing, because the root of a constant is 0, minus 10x dx. Oh, no. See, here I chose badly, right? I chose badly here. I chose badly. I don't want to take the square. I don't want to take the square. I chose badly. Because I had an x here, and I'm like, I don't have any x's up here, right? There's no x here, so that didn't work. So let's just have it be 3 equal to minus 5x. Now, if I do this, this becomes negative 5. Oh, I didn't even grab it correctly anyways. Minus 5 dx. And notice here, this should work out. Whoops. Hi. Something went wrong here. Dx. So here we have dx is equal to du over minus 5. So let's plug all this in. So here, I have 0 to, I'm going to leave this blank here and this blank here for a second. We'll fill it in 2 seconds. Let's do this. It'll be 1 over u squared du over minus 5. Okay, so how do we get our bounds? Whoops. There's a typo here, isn't there? This should be g of a. Sorry about that. There's a typo there. In the last problem, could you... Yeah, I'll show all the other stuff at the end. Okay. And the last problem, yeah, you could leave it at the earlier point. That's fine. When I'm grading it, you could have left it at any point. When WebAssigner grades it, you probably should take it all the way to the end. Okay. All right. So let's figure out here. So let's do this. So this is also equal to g of x, right? I've been just using u's for simplicity's sake, where this is also equal to g of x, right? So let's figure out what g of x of 1 is. So g of 1 is equal to 3 minus 5 times 1. What does that equal? That equals minus 2, right? And g of 2, for my other one, so g of 1, my g of 2 is equal to 3 minus 5 times 2, which is equal to minus 7. So here I'll have minus 2 and minus 7. Now notice here that the order is different, right? I've gone from a smaller number, or a number more left on the number line, to a number more right on the number line, to a number that's more right on the number line, to a number that's more left on the number line. So here we kind of swap. It doesn't, as long as you evaluate this in the correct order, you should be okay. All right, so let's go ahead and simplify this. So this becomes minus 1/5. The integral. Let's go ahead and evaluate this. So we'll take out the 5th. This becomes 1 over, we add, so this is u to the minus 2. So this becomes u to the minus 1. So 1 over that, and we bring out the minus 1, so we add another sign here. Just to make our life easier, let's get rid of the negative. We're going to evaluate this at what? Minus 2 and minus 7. let's plug that in. So here I have 1/5 times 1 over -7 minus 1 over -2. And then if I crunch through this number, this becomes, I can do math. 1/5. At this point, you type it in your calculator, but I'll do it in my head. This becomes plus 14. No, this becomes plus 7 over 14. This becomes minus 2 over 14 times the 5th. That gives me 5 over 14 divided by 5, so that's just 1/14. Yeah. Okay, so there you go. Just type it in a calculator. Okay, so what do we do here? So we just did our normal substitution here, but now if I have a bound, I got to figure out where the bound goes to. So this one goes to -2. How do we do that? We just plug it in for whatever we make our u. We're just going to plug in our value in for that. And then here, how to do this one? So this becomes, oops, that anyway, more like 7. And so here, when I evaluate this, it's going to go from -2 to 7, right? So I just plug these back in here. So that's the only thing we did different. Let's do it one more time. And this is our last problem for the day. In fact, it's the last problem for the course, or at least last new problem for the course. We'll do practice tests for the exam, trust me. All right, so let's do this. So what do I have here? I don't know what to do for any of this, right? So I am just going to let u be ln of x in this case. Now why am I doing that? Because du equals 1 over x dx. And then when I solve for dx, what do I get here? I get x du. All right, so let's go ahead and do that. I'm going to leave these blank again. I'm going to plug in. So my ln of x is my u over x, and then x du. So these x's cancel. So I'm left with nothing. I'm left with nothing with an x at this point, and therefore I know I'm good. Once I know I'm good, I'm going to plug in my values. So ln of 1, remember this is equal to g of x. So g of 1 is equal to ln of 1, which is equal to 0. And then g of e equals to ln of e. Well, these are inverses of each other, so that's equal to 1. And so here we'll have from 0 to 1. So here I just have the integral from 0 to 1 u du, which is equal to, of course, u squared over 2, evaluated at 0 and 1. That is half plus 0, so it's just a half. There we go. Okay,